Right, let's have a look at some examples. Now, as always, I would like you to have a look at the text and then make sure you understand what the resulting printouts will say, and only proceed to allow me to tell you once you've actually worked that out for yourselves. But before you start thinking about this in detail, there's a couple of things I want to say. One is, in these cases where we see two public classes on one slide, you should remember that if you try these out, and you should feel free to do so, you'll have to put them in separate files, because in Java you can only have one public class per file, and then the name of the public class must correspond to the name of the file. So what we've got here will have to live in two different files, number.java and main.java. The other thing I want to say is that, although for the sake of having you understand what's going on, we have a public instance variable x in our class number, that is a thing you should never ever do. Instance variables should be private or possibly protected, which is another variant we're going to see later on. But for the sake of argument, we're going to have public instance variables in these examples. The difference is that it means that the client of the class is able to access the instance variable directly in order to, for example, print out its current value, as you see in the main class here, which is convenient for the sake of having you understand what's going on, but actually a really bad example, so I'm a bit uncomfortable about it, but I decided not to change it, so there you go. Okay, right, over to you. Have a look at this code, think about what you think is going to get printed out by these three println statements below, and come back when you think you know. Right, this is going to print 0, 4, 5. Now, why is that? What's going on? So we're having number A equals new number. So in this first case, we get the default value of the instance variable x, because it doesn't get initialized anywhere, and so when we print it out we get 0. The next thing that happens is that we explicitly set it to 4. That's one of the things that you shouldn't be able to do from a client class if it was private, which would be much more proper, but because it's public we can. And then we print it out, and lo and behold, it's 4. The next thing we do is we create a new reference to a number object, which is b, and we make it point to the very same number object as a. So a and b are now two different references to the same number object. Okay? And then we set the public instance variable x of that one object to 5. We could have done it by going a.x equals 5, or we could have done it by going b.x equals 5. We get the very same effect. And indeed, when we have the println, we could println a.x, or we could println b.x, and we'd get the same result because a and b are the same object. They are two different references to that same number object that was created by the only new number line that we have in that main file. Okay? Next. Now, what about this one? I don't think I want to say anything in particular about this one. Just have a think. Are you back? We're going to get before change 50, and then we're going to get after change 600. Why? Because the old data value is replaced. Okay, so again we've only got one object in play. We've got a new operation which is initialized with argument 50, and so there we see in the constructor the value of the instance variable data becomes 50. And then we invoke the change method on this object. In other words, we send the change message with argument 500 to our object called op. And what that does is it adds 500 to the... no, sorry, it doesn't do that. It ignores the previous value of data. It takes its argument 500, it adds it to 100, and it sets the value of the instance variable data to be that new value. So that's 600, and so that's what we get. You might think this is slightly odd behaviour. You might kind of expect it to be taking some notice of the previous value of data, but hey, it doesn't. Next. Now, what have we got here? We've got now a class person, and we've got a class main. Have a think about this. when you think you know what it will print. Go on. Haha, trick question. It's going to print a null pointer exception. Why is it going to print null pointer exception? It's not really going to even get to actually printing anything. What's going to happen is we're going to get an error null pointer exception, and the null pointer exception is going to be raised right here when we try to invoke the length method of name. Why? Because name is a string object which actually has the value null, and the value null cannot receive any messages. You'll get null pointer exception if you ever try to send a message to a thing which is null. So that will not work. We won't ever even get to the print statement. We're going to see a few variants of this now and see which one's actually going to work. Now, what about this one? This time, what have we done? We have added an initialization for the instance variable name. So we're going to set it to be an empty string. That's going to work, because having initialized name to the empty string, it makes perfect sense to check the length of the current value of name. We will indeed find that it's 0 because it starts off being the empty string, and so we will assign to the instance variable name the new value n, which was passed in as an argument to the assigned name. That is going to end up being Lee, and so when we print it, we're going to get Lee printed out. Next variant. So we have taken away the initialization of the instance variable name, but we've got a different kind of check. This time we're explicitly checking whether or not it actually is null. Think for a moment, what's this going to do? It's still going to raise a null pointer exception, because no matter that what we were trying to do with this equals message is to check whether the thing is null, actually the effect of what we're doing is we're sending a message, in this case equals, to a thing which can't receive any messages because it's null. So that doesn't work either. Now what about this one? Still no initialization. Now we're doing name equals equals null. Does that work? Think about that for a moment. Yes, that works. You can do a double equals comparison between an object reference, in this case name, which is a reference to a string object, although in this case it's a null reference to a string object, and the literal object reference null, which is literally null. So that works. What about this one? Think for a moment. Now, what have we got? We are going to print out first John Doe and then Lee. And the point is that the initialization with the declaration is executed before the constructor body. That's a slightly odd way to put it. What are we trying to say? Yes. What we're trying to say is, up here we set name to be John Doe, and then inside the constructor, before we've actually done anything with name, we print out the current value of name. The current value of name is just whatever the initialization was, so in that case this is John Doe. Okay? Then we set the new value of name to be the thing that was passed in as the argument to the constructor, in this case Lee. Okay. Once the constructor is fully executed, that's been done, and if at that point we print out the name of our person object, then we indeed get Lee. That's not really very surprising if you think about it, but you might need to think about it. Okay, now let's go on and look at a slightly longer example. So we're going to pretend that we're designing a hotel reservation system. It's a very, very implausible and clearly fictitious hotel reservation system, but bear with me. We're going to say we're going to have a whole bunch of hotel room objects, and each of them is going to have a number and a room rate, and each hotel room is going to be associated with a representation of the days of a single month, and the idea is going to be to indicate which days the room has already been booked for. Okay? So here is a client of our hotel room class. It's a class hotel room reserver, and here is a static method of it. What's it going to do? We're going to take from the command line two arguments, start date and duration. You've seen this kind of thing in the labs. Now we're going to create three new hotel room objects, and we're going to initialize them with those arguments 1, 2, 3, 65, 65, 75. That's presumably room 1 has room rate £65 or something. Then we're going to create an array rooms of hotel room objects. This might be the first time you've seen an array of objects of a user-defined class. Not quite sure about that. Notice we're using the useful initialization of an array syntax there. Then we're going to iterate over that array, and we are going to set a local variable of type hotel room R to be the ith element of that array for each I in turn. We're going to send to that hotel room the isAvailable method with the start date and duration that we took off the command line, and then we're going to print the bookings that it has. Okay, so that is about what I said. So, how are we going to go about actually defining the hotel room class? So, each hotel room is supposed to have a room number of type int and a room rate, which is also going to be an int, which we assume represents a number of pounds. And we said we wanted it to have an array of booked dates, so that's going to be an array of booleans. And the idea is that it's going to be true at index I if and only if the room is booked for day I of the single month which we're concerning ourselves with. So here in Java terms is the API that we're going to have. We're going to create a constructor, hotel room. Remember that that doesn't have any return type. That's why we've got a blank in the left-hand column. It's going to take two integers for the room number and the rate. There's our interface for the isAvailable method, and we've got the print bookings method, which is going to print something out, so that doesn't need a return type. It's just going to have a side effect. And we're going to have a string representation. We're going to define our own toString method. Right. We're obviously simplifying because we're only considering a single month. A little trick which we're going to do is we're going to skip index 0 in the booking. So although an array has 0 as its very first index, the first element in an array is actually the one at index 0, what we're actually going to do is we're just not going to use the element at index 0. And what that's going to mean is it's going to save us a little bit of headache, because it's going to mean that we're just going to be able to say, well, the thing at index 6 is the room's availability on the 6th of the month, and so on. And you can think a little bit about what it really means for a room to be booked from day I to day j, given that people depart on the morning of the last day that they're booked on. Not terribly important. Okay, we already saw in the original client that we can create hotel room objects and then stick them into an array of hotel rooms. There's an alternative syntax for the same thing. We could create an array of 3 hotel rooms, and then we could index into that array, and in each case we could set that to be a new hotel room. It means exactly the same thing. Do notice that either implicitly or explicitly we need to allocate memory both for the array, that's going to allocate enough memory to store enough object references to be the contents of the array, and we're going to have to allocate the memory for each object. And it may be that both kinds of allocation use new, as in this case, here we have a new which is allocating space for the array, and here we have 3 news, each of which allocate space for one object. Or it might be that the allocation of memory for the array happens implicitly using this curly bracket notation, rather than there being an explicit new there. But either way, there will be, in the end, memory for both things. There's going to be memory allocated for an array of object references, and also memory allocated for each object. Right, okay, so here is version 1 of our hotel room class. We've got our instance variables. you'll be pleased to notice that they're both private this time. We've got a constructor which is just going to initialize those pieces of data, and we have an isAvailable which doesn't do anything yet except just return true. This is quite a nice trick, by the way. Quite often when you're in the process of implementing a class, you will write something which is kind of obviously unfinished, like just return true, just in order to make sure that you can check that it compiles, and so that you haven't got any typos in your method names and what have you. Okay. Right. Yes. Always use the access modifier private, even though we just saw a couple of examples which didn't. And remember the possibility of using the final modifier for those instance variables that ought not to change after their initial assignment. It helps you to document that fact. It helps the compiler to help you by pointing it out if you later accidentally write code that does modify something that you didn't want to be able to be modified. Right. So this is the first thing that we might get as a result of our printing out of the hotel room array. That's not terribly informative. We could probably want to be able to do better than that gobbledygook. How are we going to do that? So this is the result of calling system.out.println on a hotel room, on each of the 3 hotel room objects. What we have to do is we have to write a toString method. So that's how Java handles these things. So any object in Java understands the toString method, but what it does in response to the toString message may not be what you want it to do. And what you can do is you can implement your own version of the toString method in your own classes, and that will make sure that you can print something sensible. So here's what we're going to print in this case. We're going to print out the room number and the room rate, and notice that we're using the format strings in order to get the information that we want printed out, as we saw recently. And then we get a much more sensible representation like that. And you should play around with these things until you understand how to do this kind of thing. Right, now, this is kind of drawn from an example in Sedgwick and Wayne, I think, and it was drawing on a couple of things which used external utility methods, so don't worry about this too much. The idea here is that we're going to have an external utility method which randomly flips false to true and checks whether or not the rooms are actually going to be booked or not on a particular night, just for testing purposes really, so we won't worry about that too much. Now we've actually got some code in place for isAvailable, and you should study that at your leisure. I don't think it brings up any new points particularly. But the point of this slide is I think that we've now got our private array of booleans for booked, which gets initialized kind of at random in the constructor just for fun, and then it gets used in the isAvailable method. Okay. And we can print bookings using another utility method. It's not terribly interesting. Okay. And that being so, we can get a representation that looks a bit like this. So, what have we done? We implemented a toString method for hotel room, and you should remember that possibility because you'll often want to implement toString methods for your own classes. How is that actually used? Well, I told you that every object in Java understands the toString method. It's just that it might not necessarily do anything terribly useful as a result. You saw we got some gobbledygook when we sent it to an object that didn't have its own special toString method. Implicitly, Java calls this method whenever it executes something that needs to turn an object into a string representation, for example, println. Okay. Yes, and we dealt with arrays of hotel rooms, and we talked about 2 different ways of doing that. Okay, now let's talk a bit more about constructors. So, what have we got here now? We're going back to circle. So let's have a class circle1. It's got a private radius, and it's got a public method getArea, which is going to return the πr² version of the thing. Right. So what happens when we try to create new circle1 objects if the class only has that definition and doesn't actually contain any constructors? Well, as you would expect, if you try to create a new circle1 object with an argument, you're trying to invoke a constructor which isn't there, and so indeed you get a compile time error. What you might be slightly surprised by is that you can in fact create new circle objects even though there's no constructor, because there's a default no argument constructor. If you write a class that has no constructor in it at all, then Java will automatically add a no argument constructor for you. Unfortunately, it won't do anything useful, so radius will continue to have its default value of 0, and indeed when you ask what is the area of a 0 radius circle, you shouldn't be too surprised when the area of a 0 radius circle is 0. Okay. Now, suppose that we now add the constructor we're interested in, the one that takes a double new radius and sets the radius accordingly. Now what happens if we try to create a circle using a constructor with no arguments? Well, actually that's now going to cause a compile time error, because although I said Java will create for you a default no argument constructor, it will only do that if there isn't a constructor at all in the class. If your class contains any constructor at all, the Java compiler will actually perfectly reasonably assume that you did in fact create whatever constructors you wanted to have, and so if you try to invoke one that isn't there, it will complain. So how can you get around that? Well, it says not always practical to provide a no argument constructor for your classes. Yes, it's true, sometimes there isn't really anything sensible that you can do without data from the user. But here's the kind of thing you can do. You can have two different constructors for the same class. So in this case we've got one constructor that does the sensible thing and takes a radius and sets the radius to that, and we've written a 0 argument constructor which just sets the radius to 1.0, which seems like a reasonable default idea. Okay. Sometimes if the constructor is having to do a fair bit of work, it's a bit tedious to write two completely separate and independent constructors, and sometimes this trick is quite useful. You can have one constructor that calls another constructor with its argument. Okay. So in this case the constructor that really does the work is the one that sets radius to be the argument new radius, and then our 0 argument constructor is going to invoke that constructor, passing it 1.0 as its argument, and the syntax for that is this 1.0, like that, and that has to be the first line of the constructor. Very often it will be the only line of the constructor, as in a case like this. Okay, more examples. Right, back to our slightly weird operation example. Remember this one? What's going on here? Now, remember before we did get different things before and after the change. Why don't we in this case? Well, let's have a look at this. This is a bit peculiar, isn't it? So we've got our new operation with argument 50, which is going to set the data to be 50, and so then when we print it out we indeed get 50. Then what happens when we send the change method this time to our operation op? Well, in this case we do something with the data. Yes, of course. What's going on here? This is where you get into real trouble if you try using the same name for different things. We've got data here, which is the instance variable data, and we've got data here, which is the argument to the change method. And when we go data equals data plus 100, what we probably intended was for that data to be that data. We probably intended to be setting the instance variable to the argument, to the value of the argument plus 100. But that isn't what this Java code does. The change method modifies a local field. It attempts to modify the parameter itself. That doesn't work. Oops. Yes. So what we want to do if we want to have that effect is we can go this dot data. So I think the point is this is that there are several different ways in which this gets used in Java. You've seen one of them where it lets you invoke another constructor within a constructor that you therefore don't have to duplicate code in. And in this case we're seeing it used to disambiguate variable names. So when we go this dot data, what we mean is the instance variable called data of this object. And this now does what we want. Okay. Now have a look at this one. What's going on here? The key difference here is that we are making the change method of class operation take a reference to an operation object as its argument. Okay. So what's going on here? So now we're creating a new operation with argument 50 and we are printing out its data as before, so that works fine. Then what are we doing? We're sending the change message to our operation with itself as an argument. Okay, which is slightly weird, but there we go, that's what we do. And then what we're doing is we are setting the data instance variable of that one object that's in play to the old value of the data of that object plus 100. So in other words, it becomes 150. And then when we print it out, we even get 150. Okay. Sending a message to an object with itself as argument is a really weird thing to do. Don't ever do that. Don't know why this example is this way. Possibly just to show that you could. Okay, so object orientation. So far, what have we learned how to do? A data type needs a set of values and a collection of operations on those values, and in object-oriented programming that turns out to be classes. Classes can be used because of simulating the physical world, and we usually like to have as close a match as we can between the set of conceptual domain objects, so for example the objects in the real world or the objects that your customers talk about, and the classes in the system. It's not necessarily easy, there's lots more to learn about exactly how to do that, and you'll meet it later, but we've been playing around with geometric figures and with some rather implausible hotel rooms. And this lets you extend the Java language essentially, because of course Java doesn't already have a data type for every possible application. You want to be able to define your own classes in order to add your own abstractions to your systems, and now you know how to do it. We saw how to use client code to motivate and test classes. You saw how to define instance variables and instance methods and constructors. And that's the reading for this lecture.